A quick question, guys. Say we have a parallel plate capacitor. What is the capacitance of this capacitor? What is the formula? C is equal to, yes, C is equal to what? A by T into a constant, right? So basically, if I want to increase the capacitance of a capacitor, I have to increase the surface area or decrease the distance, right? The surface area I have to increase. So remember, this is 3-dimension. I'm not drawing that. Let me draw that. Or I have to reduce the distance. I have to reduce this. There's one more thing that we can do. This particular thing. What is this? It's to do with the space between the plates. So the space between the plates, it has some influence, right? This is the space. Let me not do that. Let me do it this. This space has some influence, I can do something with this space. Can I literally do something with this space? Yes. As of now, it is empty. Okay. This is empty. What can I do with that? I can keep something, right? Keep something. What can that something be? It can be a conductor. Of course, everything has certain condition. I'm just simplifying this. Or I can keep something called as dielectric. So what happens when we keep something called as a conductor? Conductor, you guys know. What happens when we keep something called as dielectric? See all of this, what happens? How can I change this? If I change this, what happens to the capacitor of the capacitor of the capacitance? Wait, capacitance of the capacitor, other way around. So what happens is what we are trying to learn in the next set of videos. So again, what are we trying to do? We are trying to, in the most layman form, we are trying to increase the capacitance of the capacitor, that is the ability to hold more charges. So with this, it can hold more charges. The catch is for same voltage, for the same potential difference, or let me use a word which you guys understand better, voltage. Okay, so that's the funda. So first we need to understand what is a dielectric, and then we will place it in between the capacitor and see what happens. So what is a dielectric? So the basic idea is it's a insulator, but with a certain property. That is, when it's exposed to an electrical field, it can get polarized. So I have an example for you guys, a non-polarized atom and a polarized atom. So the non-polarized atom looks like this. So from a person who is standing outside, this looks like there is no charge. For a person who looks from outside, we can tell that there is a charge, right? Of course, there are quite a few background to it, but I'm not going to that. I'm just simplifying it in a very simple manner. I mean, it's a very, very simplified version of a very complex situation over here. For a device, let me put it this way. For a device, if I ask it, is there some charge over here? It will read that no, there is no charge. For a device which can understand electrical field and all of that, right? Not looking at this diagram, if I ask it, is there a charge over here? It will tell yes. And for that, it will look like there's a negative charge and a positive charge, equal in magnitude and but separated by a certain distance. Here it will tell, well, as per my reading, there's no charge. So it's a simple scenario. Non-polarized scenario is wherein the positive and the negative are overlapping and they cancel each other. While over here, the overall cancellation happens, but we can tell that there is some kind of electrical field that's moving from one end to another end. So the atoms and the molecules of a dielectric, they can become this. That's the funda. Okay, yes. Again, dielectric is a material which helps us increase the capacitance of the capacitor. How? By kind of getting something called as polarized. What does polarized mean? From this, it can become this. Or in some of the dielectric, it's already this. So what happens later, we'll see. Now, but why do we need it? A simple question. So I have put it across in a pictorial manner. Say we have a capacitor with capacitance C naught and the charge on it, there's already charge Q naught. So there is a voltage reading, say V naught. Now, when we introduce dielectric, what will happen to the charge? Well, why will charge go anywhere? Charge will remain the same. There's no path for it to go anywhere. What will happen to the voltage? It will drop. Say V dash. So all you have to know is V naught is not same as V dash. And the capacitance, the new one, say N. This also I'll call it as N. I like N. That's kind of yeah. So the old will not be same as new. The capacitance of the capacitor also changes. Okay, guys. So why does it change? How does it change? That we'll be studying. Why do we need it? So basically, it's like adding a layer of rubber to this same balloon, right? We have a balloon. We are adding one more layer of rubber. So the same balloon will still hold the air, but it might be harder to break it, blow up. This allows more air to be filled before it bursts. Here, maybe the maximum charge that it can handle is 10 electron. Here, at least it will be more than 10 electron. It can be 11, 12, 13, 14. So the number of electrons that it can hold, it will increase. Basically, it's like increasing capacity of increasing the holding capacity, holding capacitance. Wait, again, I'm coming to the same word actually. Basically, we're increasing. It's a tank, and in this tank, we are seeing to that it can hold more water. Yeah, that's better. Right? For the same physical setup, for the same size of the plate and the distance and all of that, now it can hold more charges. That's the most simplest thing. It helps in storing more charges in the capacitor, thereby increasing the capacitance. Again, we know that capacitance of a capacitor, it depends on area, distance. Of course, this is for a parallel plate capacitor. And it's so for even cylindrical plate capacitor. So that formula is, if I remember, I think I remember the spherical. No, I remember log of something. Natural log of P by A, if I remember right. And this is 2, I guess. 2 pi epsilon naught, and it depends on the length. Okay, just let me. Okay, guys, this is right. So here too we can see the space. So in all of the formula, we'll get to see that the space plays a role. So in that space, we can keep some other set of materials and change how the holding changes. The amount of charge that can be present within this plates, it changes. And one of the material that we can use is dielectric. It's an insulator which can get polarized. Right? That's it. So you can pause and copy this off.